Welcome to Concept B, Graphs and Functions. This is the second notes video for this. We had previously talked about domain and range and how to write that in our interval notation, and then also how to use the vertical line test to tell if a graph is a function or not. Today in this one, we're going to explore some of those basic parent functions that we've talked about previously in Algebra 2. But we're going to discuss in particular how are they functions, and then also how do we find the domain and range of these. I will let you know that it will be very helpful for you going forward to know the basic shapes and names of these functions. So as we go through these, please go ahead and make sure to write the equation and the name so you can start associating that with the graph. So in the example here, we're just going to start with is determine the type of function, the domain and range of each graph, and then we're going to write our answers in both interval and as an inequality, so we can practice those both. Now, this first graph here should look pretty familiar. I'm going to go ahead and add some arrows here so we know that that's going to continue up. If it does not have a point there, we're going to always assume that if it goes off the graph, it has arrows. So please go ahead, always draw those in. But if I think about this, this is our U-shape, this is our parabola, and we know that this is going to be the quadratic function. We talked about quadratics way back in first semester, but this will be our quadratic function. This means here that in our equation for that quadratic function is going to be f of x equal to x squared. If it'll help you, we can make a table of values here to the side. I'm just going to plug in some values, -2, -1, 0, 1, and 2. If I plug that into our function, I get 0, 0 squared. 1 squared is 1. It'll be the same thing for -1. And then 2 squared is 4. So same thing there. And I get those points on my graph. So we know that x squared is a quadratic, so that's going to give us that. And if I look here, notice any of those vertical lines I draw are going to always hit that graph at one location, which makes this a function because it passes that VLT, that vertical line test. So let's talk about the domain and range here. Remember, domain is always how far left to right my graph can go. And if I think about this here, that left arrow, if we think about in behavior that we previously have talked about as well, that left arrow is going up, but it's also slowly growing out to the left as well. So I know that I can go all the way to -infinity, and then my right arrow is doing the same thing, and it's also going all the way out to the right, meaning that I can go to +infinity, meaning that my domain here will be that -infinity to +infinity, or you can also write that as all real numbers. Now, range, which is our y values, that is going to go from bottom to top. And didn't quite fit there. We always have to go from negative to positive. So if I think about this, for my y values, the lowest point on my parabola is this vertex here at 0, 0. And since it actually exists there, I know that the furthest down I can get is 0. And since I exist there, it's equal to 0. I'm going to put a bracket on it. And then my graph from there is going to keep on going all the way up. So that means I'm going off all the way to +infinity with that infinity symbol there, with that parenthesis. So if I were to write this as an interval, remember since we're using range, that's y values, y, and my value is 0, but y is getting more positive than 0, so it's got to be greater than or equal to since I used that bracket. Let's go to our next one here. We'll notice here, this one right here is giving us this S-curve. Kind of a flat S, but that's okay. This one right here is our cubic function. If we think about our previous knowledge about cubing, that means to take something to the third power instead of the second, like the quadratic. So this will be our function here. We can do a quick table of values if that will help. doing -2, -1, 0, 1, and 2, which if I plug that in and I cube these numbers, 0 cubed is 0, 1 cubed gives me 1, because 1 times 1 times 1 is 1, and then 2 cubed is going to give me 8. 2 times 2 is 4, times another 2 is 8. And then unlike the quadratic, these, when I go negative, are going to keep that sign. That's what gives me that negative value there, giving me that 0, 0, 1, 1, 2, 8 way up there, but then that -1 there, giving me that curve. Once again, this is going to pass that vertical line test. It's only going to touch at one location. So this is a function by that VLT. Then for our domain and range, remember domain is our x values all the way to or how far left to how far right. But since I have arrows going in both directions here, this means my domain has to be -infinity to +infinity, or I can also write that as all real numbers. And if I look at my range, how far down can I go? Well, that bottom arrow is going all the way down to -infinity, but then that right arrow is going all the way up to +infinity, so that's going to give me all real numbers. We really like the cubic function because it'll give that all real numbers for both the domain and range. If I go down to our next function here, this one's a little bit different. It kind of looks like that, but it looks like it's been cut off. This guy right here is something we talked about in a previous unit. This is our square root function. Remember that square root is going to be that radical sign x. You can assume that there's a little 2 there, but remember if it's not given to us, we automatically assume that. If we do a table of values here, again, you don't have to, but this is just showing. Remember, since it's a square root, we can only take the square root of positive numbers. So I'm just going to pick some perfect squares, those that we can take the square root of nicely. And so that would be like 0, 1, 4. And if I plug those in and I take those square roots, I get 0, 0, 1, 1, 4, 2, giving me those nice points over here, which 4 would be over there. But that's off the graph, so we're not going to worry about it. But that does mean we have an arrow here. So let's talk about domain and range on this guy. Domain, my furthest left point is at that vertex, which is not really a vertex, but I'm going to call it that just because it's the knowledge, previous knowledge that we've used. So that's at 0, 0. So that means my furthest left point there is at 0, 0. But then I'm going all the way to the right here to +infinity. So my domain here is got to be bracket 0 to +infinity. Or, since I'm using domain, x has to be greater than or equal to 0. Now my range is bottom to top. Once again, the lowest point here is at 0, 0. And then it does look like that arrow is going to level off, but it is slowly growing. So it's going to keep on going up. So I'm starting at my lowest point of 0, but going all the way to +infinity. So in this case, it would be y is greater than or equal to 0, since we're talking about range. And that's going to be our square root function. That one's going to be a little bit different, but we still are using the exact same interval notation there, just using brackets versus parentheses. Our next one here looks very similar to that cubic function we just talked about, but since we just talked about quadratic, which was x squared, and the square root, well, if we have a cube, this is going to be our cube root function, our cubic root function. Meaning, instead of to the third power, we're going to take that third root. So if I make that table of values again, I'm going to choose numbers that have a nice cube root, or in this case, just -1, 0, and 1, which just gives me those exact same answers, which we can use our calculator for. So there's 0, 0, 1, 1, -1, 1, giving us that sideways S curve. And once again, we have those arrows. Since it's going off the graph, we're going to assume that. Now this one's a little tricky because it looks like it is not going to pass that vertical line test right here on the y-axis. But if we were to zoom in on that graph, it is actually minutely getting over there smaller and smaller. So even though the graph can sometimes lie, it just is based on how far out we're zoomed. So I should have zoomed in there probably a little bit more when I made that graph. But this is actually going to pass that vertical line test. And so this is still a function. So keep that there. That is still a function. Now let's talk about domain and range. Again, I'm starting at that, in quotation marks, vertex with 0, 0. My right arrow is going all the way to the right. The left arrow is going all the way to the left. So my domain here is going to be negative infinity to positive infinity, or all real numbers. And then, yes, it looks like those arrows are going to kind of level off, kind of like they did in the square root, but the same thing, it's still going to go all the way down with that left arrow slowly going down, and then that right arrow is still going slowly all the way up. So that range is going to also still be negative infinity to positive infinity, or, once again, all real numbers. That cubic and that cubic root function are really nice for us because we don't have to write as much. And if you're lazy like I am, that's not a bad thing. Okay, let's go to our last one here. This one looks a little bit different. We haven't seen this one before. This graph right here is what's called the rational function. And we're going to do a whole unit on rational functions in the future here, but we want to introduce its basic shape. Now the key word there is ratio. And we talked about it previously, but a ratio is just another word for a fraction. So my function here is where I have 1 over x, where my variable is going to be in that denominator. So in this case, that is our rational function, is 1 over x. Now, it does look like I have two different graphs here, but it's all part of the same. I'm going to add these arrows here because it's all the same. Now, before we make our table of values, I can go ahead and set that up here. We have to look at the function. Remember, our function here is 1 over x. Well, if that's a fraction, that's, if we think about that, just really just division. And what number can you never divide by? 0. That's why, if you look here at where x equals 0, or that y-axis, that's why it looks like that graph is never actually going to touch at 0, because I could never divide by 0 and plug that in. So when I have 0 on my table of values, I don't have a value there for it to exist. It's kind of like with the square root function where I can't take the square of negatives. For the rational, I can never have 0 there. But if I were to plug in some other numbers, like -2, -1, or 1 and 2, that would give me -1, -1/2, 1, and +1/2. And if I look there, those are the values I'm getting for those points. And that's where that curve is coming from. So, same thing, that means that if I can't let x equal 0, that means there's never a chance where y is going to equal 0. So I'm going to put that line there as well. So for my domain, if I look at my arrows here, it does look like if I start at 0, 0 like I normally do, I can go all the way to the left because of this left arrow here. And then I can also go all the way to the right because of that right arrow there. But since I can't actually be at 0, it's kind of like I have a hole there. So my domain here is going to be -infinity to 0. But since I can't actually be 0, I'm going to put a parenthesis on it. And then I'm going to pick right back up and go all the way to the right with that positive infinity. But I have to put that union sign in between to connect those, if we think back to the last unit, or to the last video. So to translate this into an inequality, let's start with that first one. So this is saying, hey, x is strictly less than 0, or x is strictly greater than 0. It's giving us that or with that union sign. If I do the same thing with my range, we'll notice something very similar. My bottom arrow is going all the way down, my top arrow is going all the way up, but I still can't exist at 0 there, meaning my range is going to be the exact same as the domain. But instead of using x, I'm going to use y in my inequalities. And this is going to finish up our concept B notes. Please go ahead and review and practice and try to memorize these shapes, the names, and these graphs because it will serve you great in the future.